Now that we've finished our initial exploration and improved our design, we're ready to perform a more detailed analysis by performing a high-fidelity simulation. In the Stage Navigator at the bottom of the window, click on the right arrow to activate Refine Mode. We can use this mode to complete our thermal analysis of the design. The Refine stage allows us to perform a conjugate heat transfer simulation. This kind of simulation lets us combine the fluid dynamic analysis with the solid thermal analysis, and will allow us to accurately predict the temperature that each component of the PCB would reach while operating. Use the model tree to show the completed PCB and heatsink. Then, hide the fans, board, housing, and the extracted volume. Let's prepare the model for simulation by setting the materials for the different components. For this example, we will use the materials already available in Discovery, but you can choose to modify the material properties as you see fit. Select the two heatsinks, Heatsink and Component 2, and set the material to copper. The change in color indicates the material selected. For this exercise, we can assume that the capacitor is made of aluminum. Last, hide the heatsinks and capacitor in the structure tree. And select the remaining chips. We can choose silicon as the material to assign to these components. Now, let's set up the thermal conditions for these solids. This will trigger the simulation to become a conjugate heat transfer analysis. This type of simulation accounts for the heat transfer between solids and a surrounding fluid, such as air. Click Solid Thermal from the simulation toolbar. Now, click and drag a box around the three CPU bodies and enter a value for the total heat of 200 watts. Then press Enter on the keyboard. This is the same load we used in the heatsink example. Let's apply the rest of the heat loads to the components in the assembly. Unhide the capacitor from the structure tree. With the solid thermal option active, click and select the capacitor and enter a value of 2 watts. Do the same for the smaller chips, selecting them one by one. Set a total heat value of 5 watts for each of the chip 2 bodies and for component 1. Select the items one by one. In this example, we want to analyze only the chip's temperatures. In the model tree, make sure to exclude the board, housing, fan housing, disks, and hubs from the simulation by clicking on the circle on the left. These components will be omitted in the solution. Set the initial fluid temperature to 20 degrees Celsius. Set the same temperature for the inlets Note that the swirl at the inlets needs to be set to positive 1200 RPM due to the different convention used in Refine mode. And then open the outlet boundary condition and set the temperature there to 20 degrees Celsius as well. The last step is to change the default convection thermal condition to insulated for the bottom side of the solid components. Select all the bottom faces of the solid bodies. And then set the thermal condition to insulated. Save the model. In the next part, we will run the simulation and analyze the results.